dOrg hot seat. Vocdoni is a secure, censorship-resistant, anonymous voting protocol, and I'm really excited because the first thing that a lot of people thought when blockchain came out is that it's really good for voting and stuff, but it turns out that voting on chain is basically a nightmare and extremely susceptible to bribing, to the point that you can automate bribing at a large scale with automated payouts, smart contracts, etc. Really excited for today's call. All right, without further ado, we can go with Pau, who is the CTO of Vocdoni, and Mark, who is a full-stack developer at Vocdoni. Let's take it away.
Thank you, Paul. You're amazing. And thank you, Clara, also for inviting myself and also Mark. I am Pau from Vocdoni. I'm one of the co-founders. Just a quick presentation of who we are. Vocdoni is a project that was born back in 2018. So Vocdoni's vision is to improve the democratic health and promote the participatory governance using decentralized and open source technology, right? That's a quite wide vision, but that's what we do. And we do it by implementing a voting protocol that we started back in 2018. We were focused on the Web 2 world, not in the Web 3. So that's probably why some of you maybe never hear about our project, because we have been focused on trying to solve this problem for the traditional world, let's say, and not in the Web3 world. But in 2021, Vocdoni project was acquired by Aragon Association. And from that moment, we are also focused on the Web3 world. There are nice things that are coming that I will present right now. So yeah, the Vocdoni protocol is mainly implemented on a layer 2 blockchain. We are using Tendermint. Initially, we tried to fork Ethereum and then to make, let's say, a proof of authority network able to process votes, let's say, in a fast way, but it was not fast enough for our needs because we wanted to support nation-size elections. So we end up implementing our own layer 2 blockchain solution. Right now, it scales very well. We have around 800 transactions per second. The main functionality of this blockchain is to process votes and to configure elections. We don't have gas. We don't have smart contracts. It's very optimized just for voting and for processing ballots. This layer 2 blockchain is zk-SNARK native. We have support for anonymous voting by using zk-SNARK technology. We are using Circom from Jordi Bailina. It's currently a proof of authority, but we are migrating it to proof of stake. Right now, most of the validators are from the Vocdoni organization, but there are some of them that are part of some public institutions like universities and so on. You can check a bit the protocol if you go to the Explorer. It's the explorer.vote, the URL. And there you can see the transactions, you can see the votes, the processes, the data structures and everything if you want to see a bit more about it. And then right now, on top of this protocol, we are building 3 products mainly. The main one right now is Vocdoni.app. Vocdoni.app, which is a front end that uses the protocol for Web 2 organizations, meaning that, for instance, we do not integrate MetaMask or Web3 signers. The signer is integrated inside the browser, so the user has an experience which is very close to a web page. Actually, today we just released the new Vocdoni.app version, which includes many improvements. You can check it out if you want. You can create an account; it's for free. You can try to create a voting and vote. You will see that the way to configure an election there is very, let's say, simple. You need to upload a CSV file with the credentials of the voters, and then the census is created and everything goes in order to make the users cast the vote. Then the second product that we have is called voice.aragon.org. This is to make voting over Web3 context, let's say ERC20 tokens, for instance. So you can register an ERC20 token. Once registered, then you can create elections and users that hold this token can vote. This is similar to Snapshot. There is a big difference here that we use another technology for verifying users. We use Ethereum storage proofs. This is a Merkle proof that you can get in any Web3 endpoint, and then cast the vote, proving that you are a holder of this token using this proof. This product is currently discontinued because, we are releasing the next product, which is not yet out, but it will be soon. And we hope this new product will substitute the needs of voice, because I think we are not very good doing front end or visual products. So in this new Vocdoni iteration, we are focusing on being a protocol player. So we want to put most of the effort on the API and the SDK, and let people like you guys, for instance, build products on top of that. Because I think the protocol is very, very powerful. It allows a lot of different kind of votings, a lot of things. You can do a lot of things with the protocol, but the front ends are very simple. I hope that maybe releasing this new API, people with better skills on product building will be able to get the power of the Vocdoni protocol. So yeah, this is a TypeScript SDK and a REST API. It's very easy to use. You will see here you have a very simple example on how to create an election. This is what you need to specify: title, description, header, end date, start date, and the election type. There are some properties here like is it auto start? So should it be started in the start date, or you want to send the signal for starting it? Is it interrumpable, for instance, means do you want to make it alive until the end, or you want to stop it, be able to stop it before? Or dynamic census, is the census changing on the time of voting or not? Secret until the end is like, do you want to have encrypted votes and release the private keys at the end or not? Anonymous, you want to use zk snarks or not, for instance. And there are much more options, even more that you can see here, but these are the most important. So just creating this data model and sending it through a transaction to the layer 2 blockchain, you are creating an election with all these properties. So some of that fields that you see in the previous slide are what we call it the ballot protocol. And I think that's important because it's something that we are not supporting in any of our visual products, but is in the protocol since long ago. It's one of the examples. The ballot protocol specifies how the ballot is encapsulated, so how the voter is encapsulating the data inside the vote before sending it, and how is it accounted in the protocol. So you have just a few options, which is max count, max value, unique values, max total cost, cost exponent, blah, blah, that can be set in order to achieve any kind of voting, like ranked choice, multi-choice, or even quadratic voting. You know, if, for instance, for quadratic voting, you can set the cost exponent to 2, for instance, and you have quadratic voting, or you can set it to 3, and then you have, I don't know, how is it called, but quadratic plus 1 voting, something like that, right? So you can play with these values, and you can create many kinds of different voting experiments, and I think that's one of the nicest things of the protocol. So what's the election flow? Just to have a brief idea on how it works. So first, you need to build a census. The census is built off-chain. It's not built in the layer 2 blockchain. And is not built in Ethereum. Usually, you can build it in Ethereum if you want, but that's not the idea. The idea is that you build a census. Census is a Merkle tree, so you need to take the addresses you want to participate in the elections and the weights, and put it all together inside the Merkle tree. And then you have the Merkle tree hash root is this what we call the census root. So that's the first step, building the census out of the data that you want. The second step is to create an account. You need to have an account into the Vocdoni blockchain. That's for free, but you need to send a transaction. And you can use MetaMask as signer for sure, or any other signer that you want. We are fully compatible with Ethereum in terms of cryptography, signatures, addresses, and so on. Then once you have the account created, you create an election using the data model that I showed before. That's encapsulated inside that transaction. You set the census root that you want to use on this election, and then you send this transaction to the blockchain. And then once this transaction is mined inside the blockchain, the election is alive, and users can cast the votes by fetching the proof of the Merkle tree that is the census, proving that they are eligible voters and casting the vote. And once the election is finished, then the results are computed inside the blockchain, and they are part of the blockchain state, meaning that anyone can check that the results are actually the correct ones, either by checking the the blockchain state, or either by adding a node to the blockchain and computing the same results. But what can we do with these results, right? Because we have it in the Vocdoni blockchains, how these results are going back to Ethereum. Yeah, that's a very hard topic, and we have been making research on this topic for the last 2 years. And to be honest, we don't have yet the greatest solution that we are looking for. Currently, you can just upload the results in an optimistic way to Ethereum via transaction or Chainlink. And then usually you need to have a committee or a multisig or whatever kind of mechanism in order to ensure that these results are correct. The nice thing here is that anyone can actually check that the results are correct by reproducing the same state of the Vocdoni blockchain. So, I mean, there can be a discussion about these results, but getting a consensus on what's the correct or not, it's very easy because it's deterministic. Our main goal in the near future is to enable result pending execution on Ethereum. This is becoming more and more feasible thanks to Ethereum 2 and all the improvements and all the ZK snark technology that is coming. Right now, we are designing a ZK bridge that will allow us to upload the Vocdoni blockchain state root to Ethereum in a secure and trustless way. So once we have the state root of our blockchain verified inside Ethereum, then we can prove any data that exists in our Vocdoni blockchain. So in that case, we could bring the results back to Ethereum in a trustless way. The new API will be ready very soon. Actually, if someone wants to play with it, we already have some beta versions that can be shared. And you can play with it if you are interested, or if not, we will publish it anyways in a few weeks for sure. You can join us in chat or in the GitHub or the Twitter if you want.
Amazing. Wow, tremendous work and still so much to do. That's fantastic. Thank you so much, Pau. I'm going to start with a question that needs to be asked. You already said that you're focusing on off-chain or like non-Web3 use cases, but we have to admit that token voting is the major standard in crypto. Even Vitalik has said that it's definitely a terrible solution. We're not doing it right. But what needs to happen for it to change within Web3?
That's a very hard question, Paul. I'm not sure. I think the big problem for Ethereum is the identity layer and the civil attacks probably, and the whales holding most of the tokens and then making democracy fail. I think we need better identity projects and civil attack mechanisms in this sense. Yeah.
What I'm understanding from here is that it's very hard to build this census that you were talking about on Ethereum, right?
Yeah. We say that the identity and the census we are agnostic to these layers, let's say. I mean, we process both and we accept censuses, but the census is built off-chain, and that's not what we are focusing on. So yeah, probably we need some other projects to look at in order to make this census civil resistant.
Excellent. I think the first question from our members comes from Andre.
I saw there's a parameter there when you create the poll called dynamicCensus, and I'm curious what that does because it was false. What does it do if you set it to true?
Yeah, if you set it to true, then you can change the census while the election is still running. So usually you build the census, then you vote on that census. But if you enable this option, then the organizer of the election can change the census in any time. So that's, for instance, for a use case like change.org, for instance, where new people is being added to the census, then the organizer is upgrading the census route in order to allow the new signers vote, for instance.
Okay, I have a follow-up on that. So if it's on false, that means while the voting takes place, even though a user changed their balance, it's not going to reflect in the weight of their vote, correct?
Yeah, correct.
Thank you.
Thank you to you.
Yeah, thanks a lot for your talk. I mean, super interesting stuff. Just maybe summarize briefly. My understanding, you have your separate blockchain, EVM-based blockchain, and you try to route it at some point in the Ethereum mainnet or somewhere, and you're using ZK Snark. My question is, how do you achieve anonymity in the sense that I vote? It's not clear yet that I hold this many tokens and that I'm this kind of person. So like on Ethereum mainnet, you can track back identities quite easily, and even if you don't put a name to it, you know who voted for what. So I wonder how you achieve anonymous voting, or if you do.
Yeah, that's a nice question. Well, first, our layer 2 blockchain is not EVM based, is built from the scratch, and it doesn't contain an EVM inside, just to point it. And how do we achieve anonymity? We have this ZK Snark circuit where you prove that you belong to a census without showing who are you inside the census. So that's the basic thing for making this anonymous voting. But, and here you are very right, if you use the weight, so if you vote with the weight of the number of tokens that you hold, then it's usually quite easy. Even if you are being anonymizing your identity, you can be tracked by your weight or your number of tokens, right? So that's a big problem. This problem could be fixed with some kind of homomorphic encryption. We are not doing that for now because also it's very costly, and also mixing ZK snaps with homomorphic encryption is something that at least blows my mind. I'm not sure if that's even possible. But what we want to do, because that's not implemented, by the way, in any of our products, is instead of voting with your specific amount, you are emitting several votes with a fixed size amount. So for instance, you can vote with 1, 5, 10. And then if you hold 50 tokens, you could, for instance, cast 5 votes of 10, right? So this way you are mixing your vote with some other voters. Is this answering the question?
I guess, yeah, to some extent. I mean, the question, maybe very, very quick follow-up, if I may ask. So these tokens that you mentioned, they live on that same blockchain, or you're using tokens that live, I don't know, on Ethereum blockchain?
The thing is that these tokens do not live in the layer 2 blockchain. You can make elections from Ethereum, from Solana, from Cosmos, whatever you want. The thing is that someone needs to build this census. And in this census, you will put the information of the addresses on the tokens that each address has. And this census is built out of the layer 1, out of our layer 1. So yeah, either you build it on chain, on Ethereum, for instance, if you can do it, or Polygon, whatever, or you build it off chain in a server in your house, I don't know, or in a multi-sig party.
Cool, thanks.
Right, so the census already contains your voting weighting and everything.
Yes.
Excellent. I'd like to ask another more question. If I can prove that I belong to the census so I can vote, could I also prove to a potential briber that I also voted a particular thing so I can get my reward?
Uh-huh. Very good question too. I would say this is the biggest problem of the e-voting solutions in general for the Web3 space and also for the traditional world. Yes, you can right now. You have this nullifier, which is an identifier of your vote that doesn't identify to you, but it's what you use for tracking your vote in the blockchain and to be sure that your vote is included correctly in the blockchain. And you could theoretically build a second snark proof, changing some parameters on the proof creation, and producing the same nullifier. So yes, you could show a third party that you voted something, and that's a big problem. The way we want to solve it, which is not yet implemented either, but we have a design, is to add a second ZK snark. So we will have a first snark for anonymizing the voter, and a second ZK snark for mixing your vote with many other votes. It's a kind of ZK rollup mechanism, but it must be a recursive ZK snark in order to be able to process this anonymous proof and then mix the vote with others and then cast the final proof to the blockchain. That's the plan that we have for solving this issue.
Really looking forward to that.
So you mentioned wanting to focus more on the front end of Vocdoni. What are a few apps in your space that excite you from a UI, UX perspective? Something you could draw inspiration from?
I'm not a front-end guy, to be honest. I'm not sure I can answer this question.
Maybe we can reformulate the question to, in what sort of flows would you like Vocdoni integrated?
Any flow. I like the snapshot front end, to be honest, and I like the flow there. And actually, I also like the flow that we currently have in Vocdoni.app. But to be honest, I'm not a product, neither a front-end guy, so that's not something I can answer.
Okay, that's fine.
Yeah, so we were discussing about making the votes anonymous and not allowing the public to infer even by the weight who the author of the vote is. I was wondering if in that context you can still grab the data points that would show some meaningful stats. For example, the turnout, how many people voted out of the total, addressable voter population, or how much weight out of the total supply, stuff like that. Can you still grab that at some point and aggregate it?
Yeah, you can grab all this information, and this information is actually public in the blockchain. So sure, you can grab that, because at the end this is summarized inside the census. So even if it comes from another layer or layer 1 or whatever, the information is there, and you have all this also in the layer 2 blockchain. I'm not sure I am understanding your point, but it's my thinking.
Yeah, because if the goal is to not make it obvious who voted, it seems like that particular information would be missing from anyone, including the app.
Okay, but in the case of if you use homomorphic encryption, there you are actually hiding the weights, and you only have the final weight. So the sum of all the weight that already voted. Still, you have the turnout here because you have the total weight. And if you use the approach that I was talking about, which is rounding it to specific size. So if you have 50 tokens, then you vote 5 times with 10 tokens. You still have the turnout, because the turnout at the end is the sum of all the weight that voted divided by the total supply of this token.
Thank you.
Okay.
All right, one last question that comes from our amazing Paul. What is the difference between ballot obfuscation and voter anonymity?
I would say ballot obfuscation in this case is encrypting the ballot. So you are encrypting your choice, while anonymity in terms of identity means that you are hiding who you are. So you can have both, or you can have only one. Usually in the ballot obfuscation, at the end, you are able to see the ballot because you want everyone to compute the same results. Or maybe not. There are some scenarios where the organizer doesn't want to make the result public. In this case, the ballot obfuscation will be obfuscated forever.
Excellent. With that, we have reached time. Wow, Pau and Mark, thank you so much for coming. This has been one of the most exciting and technical discussions that we have had. Thank you for showing us everything. Thank you for showing us the SDK that you're building. It does seem quite easy to start implementing this, creating votes. So I hope that with this tool, many other projects will start seeing that we can do better than Snapshot. We can do better than token voting. Thank you so much for showing us.
Yeah, thank you to you, and amazing questions, by the way. That was great.